You don't need to buy an AC unit this summer. You need a fan, a bowl, and something already sitting in your freezer. In the next few minutes, I'm going to turn a regular fan into something that actually drops the temperature in a room. No installation, no window unit, no electricity bill spike. Summer heat waves can be unbearable, with traditional air conditioners often proving expensive to purchase and operate. But what if a cost-effective solution existed using items you already own? This popular DIY cooling hack is remarkably simple. Just place a bowl filled with ice or frozen water bottles directly in front of your circulating fan for immediate relief. When air passes over ice, it cools down. The fan's job is to circulate this slightly cooler air, creating a localized draft that offers a refreshing sensation. It's basic physics. Heat naturally transfers from warmer air to the colder ice. This energy exchange lowers the overall temperature of the air that the fan then pushes towards you. While the fan just moves air, the real cooling comes from the ice. As air blows over the ice, it cools slightly, but the magic truly happens through evaporation. Evaporative cooling is a natural process, where water absorbs heat from its surroundings as it turns into vapor. This process draws heat directly from the air blown by the fan. Think of how sweat cools your body. As moisture evaporates from your skin, it absorbs body heat. Evaporative coolers, including this DIY version, harness this same principle effectively. Ice can cool air through direct melting and evaporation. When ice turns directly into vapor, sublimation, or melts into water that then evaporates, it continues to pull heat. The combined effect of air cooling over ice and evaporation creates a stream of air noticeably cooler than the ambient room temperature. This is how the DIY unit provides relief. While it provides noticeable cooling, this hack isn't quite a traditional air conditioner. It doesn't dehumidify. Instead, the evaporation process adds moisture, altering the air's humidity level. The effectiveness of this evaporative cooling method is highly dependent on your environment's humidity. Low humidity is key to maximizing the cooling potential of this DIY setup effectively. Evaporative coolers are best suited for dry climates with relative humidity below 50%. In such environments, the process of water evaporating can successfully reduce ambient temperature. In areas with low humidity, evaporative coolers, including this DIY version, can successfully reduce the ambient temperature by 5 to 15 degrees Fahrenheit, offering significant relief. Conversely, high humidity significantly hinders evaporative cooling. When the air is already saturated with moisture, water struggles to evaporate, reducing the cooling effect drastically. In humid conditions, every degree of temperature cooling achieved typically comes with a roughly 2% to 3% increase in relative humidity, making the air feel sticky and heavy. When humidity rises due to evaporative cooling, the increased moisture can make the air feel unpleasantly heavy and sticky. This defeats the purpose of staying cool and comfortable. A clear sign that humidity is too high is condensation. Look for water droplets forming on cold surfaces like glasses when using the fan and ice method in a humid room. For optimal cooling, frozen water bottles often last longer than ice cubes and create less mess. Consider a larger ice block for even slower melting and sustained coolness. The material of your ice container also impacts cooling. Metal bowls, like stainless steel, are excellent at retaining cold, helping to keep the ice frozen for longer. A faster fan speed yields better results. It circulates more air over the ice and through the room, enhancing the cooling effect and distributing the chilled air more effectively. Position the bowl of ice close to the fan, directly in its airflow path. Angling the fan slightly downwards can also help direct the cool air more effectively towards you. An exact ice-to-fan ratio is elusive and highly variable. The ideal amount depends on room size, temperature, humidity, and fan power, so experimentation is key to optimization. Adding a damp towel behind the ice bowl can enhance the evaporative effect. The fan then pulls air through the towel and over the ice, creating a mini swamp cooler. This method is most effective for cooling your immediate personal space, rather than an entire room. It provides a direct blast of cooler air exactly where needed most. Don't expect Arctic temperatures. The goal is to lower the temperature in your immediate space by a few degrees, just enough to take the edge off the heat. This method provides localized relief but won't cool an entire room like a standard AC unit. It's best for personal comfort when you can feel the direct airflow. An unexpected benefit is the sound. Unlike the often loud hum of a compressor in traditional AC units, this DIY setup provides a gentler, more ambient white noise. Unlike some air conditioners that can dry out the air and cause sore throats or dry eyes, this method, when used appropriately, avoids these uncomfortable side effects. This DIY approach uses considerably less energy than a traditional AC unit. It leverages natural physical principles, offering a sustainable and budget-friendly cooling solution for small spaces. For a grand total of $0, or very little cost if buying ice, this hack provides practical relief during a heat wave. It's an empowering way to solve a cooling problem. This DIY fan and ice system is most beneficial in dry climates, especially in small enclosed spaces like bedrooms or offices where direct airflow can provide immediate comfort. It's important to manage expectations. This method is designed for personal cooling zones, not for reducing the temperature of an entire large room or house effectively. If you live in a consistently humid area, this method's effectiveness will be greatly reduced. Consider other cooling solutions or supplemental tools in such conditions, or use it sparingly. Positioned correctly, this hack stands as a cheap, effective alternative for localized cooling, especially for individuals on a budget or in situations where traditional AC isn't feasible. The science behind this popular hack is evaporative cooling, a process that uses water's phase change to absorb heat. It's a simple yet effective method for personal comfort. Remember, the biggest factor for success is low ambient humidity. For the most effective cooling, aim for environments with relative humidity below 50% for optimal evaporation. While effective for personal comfort in the right conditions, this hack cannot mimic the comprehensive room cooling and dehumidifying capabilities of a standard air conditioning unit. The best setup can vary. Experiment with different frozen materials, bowl types, fan speeds, and placement to discover what works most effectively for your specific environment and needs. Always ensure electrical components like your fan are kept safely away from melting ice and water to prevent electrical hazards. Use a stable surface for your setup. Using a hygrometer, a device that measures humidity, can help you understand your environment. This allows you to predict how well your DIY cooler might perform. For slightly larger areas or to amplify airflow, small desk fans can be used in conjunction. Position them to push air over separate ice bowls, creating a wider cooling zone. Good ventilation is crucial. Ensure the room has some airflow, opening a window slightly if needed to prevent excessive humidity buildup. This aids the evaporation process. Frozen water bottles maintain their form longer than crushed ice, releasing cold more gradually. This means you'll need to replenish your ice less frequently for continuous cooling. This DIY fan and ice cooler is your best bet in dry climates, below 50% relative humidity, for providing localized cooling, offering a temporary, cost-effective reprieve from sweltering temperatures. Its effectiveness diminishes significantly in high humidity environments, above 50% relative humidity, where evaporation is less efficient, and it adds moisture rather than removing it. The amount of ice needed isn't fixed. As the ice melts, you'll need to replenish it for continuous cooling. Cooling heat effect lasts as long as there's sufficient cold mass. While the fan might be an existing item, the free aspect primarily refers to the absence of electricity costs and refrigerant chemicals associated with traditional air conditioners. The beauty of this hack lies in its simplicity. No complex wiring, no expensive parts, and no tools are typically required. It's accessible for most people to try. Compared to filtered AC air, this method doesn't purify the air. It simply cools it. For those concerned with air quality, traditional AC or air purifiers are better options. The amount of water vapor added depends on how much ice melts and evaporates. In a sealed room, this could noticeably increase humidity, impacting comfort and potentially causing mold. This method cools air by transferring heat to melting ice. It doesn't go below the freezing point of water, so don't expect sub-zero temperatures or freezing output air. The rate of ice consumption varies greatly. Larger ice blocks or frozen bottles will melt slower than ice cubes. Expect to replace ice every few hours for sustained cooling. While any fan can work, a more powerful fan, like a box fan, can move more air, potentially enhancing the cooling effect. Tower or pedestal fans also offer good circulation. For targeted relief in dry conditions, this fan and ice method is an economical, low-energy solution. It provides a noticeable cool breeze without the expense of traditional AC. By creating a direct flow of chilled air, this setup effectively cools your personal space, making it a great option for desk work or bedside cooling during hot nights. The entire cooling principle hinges on evaporation. Maximizing evaporation efficiency by ensuring adequate airflow and low ambient humidity is the secret to this hack's success. The hotter the ambient room temperature, the more heat energy is available to be absorbed by the ice. This means the cooling effect can be more pronounced in hotter environments. Ultimately, this fan and ice method is a practical hack. It effectively uses scientific principles to provide temporary localized cooling when traditional AC is not an option or is too costly. Understanding evaporative cooling and humidity allows you to harness the power of simple household items. This DIY approach proves that effective, personal cooling can be accessible and affordable. Ready to beat the heat? Try this fan and ice hack in the right conditions and feel the difference. Share your results and experiences in the comments below.